Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Dini Hanani bin A.RAHAMAN and my group members are Azul Fikri bin Azmi, Muhammad Fauzan Fakri bin Muhammad and Muhammad Aidil Haikal bin Biamin. So today we would like to presenting about the subtopic of application of differentiation, the apply maximum and minimum problems. So let's get started. I would like to introduce a bit about this topic. What is this topic is actually for? Is it useful? This topic can be defined as the process that generally called optimization. The motive is to determine the maximum and minimum values of particular functions. For example, it is used for the cost, strength, amount of material used in building, profit and loss in our real life, such as inside the business part. Next, how to solve the problem? There are three steps that we need to contribute in order to solve this problem. First, we need to find out the derivative of the function. Next, we need to adjust the derivative equal to 0 and solve the value for the variable. And last, we need to do the second derivative test. If the derivative is higher than 0, then it's meaning that the value gain is minimum, while if the derivative is lesser than 0, it's meaning that the value have been obtained as maximum. So next, the problem statement will be included in the example that Fauzan will be take over.
To make a cylindrical can to hold 2005 cm³ of sardine, find the dimension such that the surface area is as small as possible. We write down the formula for volume. V is equal to 2 pi r square h. The given 2005 cm³ is a value of volume. So we write down, we want to find out the surface area. We write down the formula for area for cylinder. A is equal to 2 pi r square plus 2 pi r h. A is equal to 2 pi r square plus 2 pi r 2000 over r square. This value is a rearrangement of this equation. We can get the value of h by rearrange this equation. A is equal to 2 pi r square plus 4000 pi over r. We rearrange it back as for us to easy to solve it, because we want to differentiate it later. A is 2 pi r square plus 4000 pi r to the power of -1. We differentiate this equation, become like this. Is equal to dA over dr is equal to 4 pi r negative 4000 pi r to the power of -2. dA over dr is equal to 0. 0 is equal to 4 pi r minus 4000 pi r to the power of -2. And then we rearrange it back, it becomes like this: 4000 pi r to the power of -2 is equal to 4 pi r. 4000 divided by 4 is equal to 1000. Pi we cancel out, become, and the r, we move it back, is equal to r. 1000 is equal to r to the power of 3. Square root 3 for 1000 is equal to 10. Right, we get the value of r. Now we can find out the value of h. The value of h is equal to 2000 over r squared. We substitute the value for r, 2000 over 10 to the power of 2, and then we get the value of h, 20. Next, we need to differentiate an area, dA over dr. You help us find out whether at the value of r equal to 10, whether we have the maximum or minimum value. Hopefully we get the minimum value. So we further differentiate dA over dr, become d square over d square a over dr square is equal to 4 pi minus 8000 pi r to the power of -3, and we already got the value of r. Now we substitute the value. 4 pi minus 8000 pi over 10 to the power of 3 is equal to 4 pi minus 8000 pi over 1000 from 4 pi plus 8 pi is equal to 12 pi. D square A over dr square is more than 0, so it is minimum value, and this proves the application of differentiation apply in our daily life. Thank you.
What a nice explanation there from Fauzan. Next, Adil will presenting his own example.
What is the maximum area that can be enclosed with 600 meter of fence? So, this example is about to find a maximum area that can be enclosed with 600 meter of fence. Firstly, we have to find the area. So we use a formula A equal to X multiplied with Y. We know that 2X plus Y equal to 600. So we bring 2X to the right and left the Y at the left. So the area is, we multiply 6 minus 2x with x, then we will get 6x minus 2x power of 2. To maximize the area, we need to differentiate this formula. So we will get 600 minus 4x equal to 0. When x equal to 150, we get this amount by minus the 600 minus 4x equal to 0. Then we will get x equal to 150. So is it a maximum? So to find is it a maximum, we need to further differentiate this equation. Then we will get -4 for all the x. So -4 is smaller than 0, so it is a maximum. So to find the maximum area, we need to find a y first. So to find a y, we put the amount 150 into the first equation. So we get 2 multiplied with 150 plus y equal to 600. Then we calculate, we will get 300. So to get the maximum area, A equal to 150 multiplied with 300, and we will get the maximum area, that is 45,000 meters square.
So next, Azul will presenting his part.
Let's take a look at the third example. Figure shows a piece of wire length 130 cm is bent into the shape of A, B, C, D, E, F, G, and given that PC right here, equal to DE. For the first question, express X in terms of Y. Okay, for this question, we can use the way that we solve parameter equation, since the question already gives us the total length of wire, which is 130 cm. Therefore, we will get 4x plus 8y plus 10. For the BC part, we can see that AG is 2 times larger than BC. So we can conclude that BC is 2y and BC is equal to DE. And then we will take 10 and take it to the right side. And then we solve it, and then we get x equal to -2y plus 30. Moving on to the next slide. And for question B, It shows that the area enclosed by the wire is A. And for question B, it shows that the area enclosed by the wire is A equal to 200 y minus the y squared. So we need to prove the area. So what we need to do is we need to create our area equation first, which is for rectangular is width times length. So we just 4y times x plus 5 for A, B, G, F plus 2y times x for C, D, E, F. Then we solve it, we will get 4xy plus 20y plus 2xy and 6y plus 20y, and then we just replace the value of x from the x that we get from the question A, and we will get negative 12y squared plus 180y plus 20y, and we will get 200y minus 12y squared, just like the question asks. And then for the question C, which is related to our main topic, which is the maximum. Okay, in order to solve this, we just differentiate the area that we get before. In this problem, I will just use the area that we get from question B, and then after we differentiate it, we let dA dy equal to 0, and then we take negative 24y to the right side, and then we take 24 to the left side, which means 200 will be divided by 24, and we will get y equal to 8.33 centimeter. For the next step, we differentiate dA per dy, and we will get the value of negative 24, which is below the 0. Therefore, the value of y is max. Since the question asks for the maximum area of the shape, we just simply replace the value of y in the equation earlier, right here. A equal to 200y minus 12y squared, and then we will get the value of 833.33 centimeter square, or you can also write the answer 2500 divided by 3 centimeters squared. Thank you.
So to conclude this, we can say that the applied maximum and minimum problems can help us to deal with our daily life problems. It easier our way in making plans for work such as business because of its function in aiding the company financial problems. We need to always appreciate and apply the things that we learn because it will be a great help in the future. So this is the reference that we have used. That's for all from us. Thank you.